Large language models are no longer just language models. They are becoming the general interface through which almost every kind of data is passed. Text becomes tokens. Images become patches. Audio becomes frames. Video becomes latent chunks. Code, user interfaces, molecules, and robot actions can all be rewritten as sequences. Take a molecule. To a chemist, it is atoms and bonds. To a predictor, it can become a stream of symbols: carbon, oxygen, nitrogen, bond, branch, ring. The object is different, but the format has been made familiar. Once the world is in that format, the same operation can be applied everywhere. Read the context. Estimate a distribution over the next piece. Choose a continuation. Then feed that choice back in. The important object is the distribution. The model turns a context into scores, the scores become probabilities, and only then do we pick a next token. The answer is not a single certainty. It is a sampled path through this probability landscape. And this works astonishingly well. The same kind of predictor can write, draw, translate, code, plan, imitate style, and search through patterns across many domains. This is not a small achievement. It is one of the clearest discoveries of modern AI. But we should name the operation precisely. It is not empty randomness. It is controlled sampling from a learned space of possibilities. That can produce surprising combinations, but surprise is not the same thing as understanding. The limit appears when we ask why. Why this answer? Why this plan? Why this molecule? Why this claim? The output is readable. The internal reason is distributed across vectors, heads, layers, and features. Scaling can make the behavior better. It can make answers smoother, tool use stronger, and surface intelligence more convincing. But as complexity rises, explainability can fall. A bigger black box is not more explainable. It is often less. Mechanistic interpretability is the first serious attempt to open that box, and the middle is not empty. Components read and write to one shared channel, the residual stream. Concepts live there as directions, but more concepts than dimensions, so they overlap, packed in superposition. Sparse features can pull them apart, and an attention head can be read as routing, which tokens to look at and what to copy. But finding a piece is not yet explaining the computation. A probe can read a concept off the activations. A feature can light up. A neuron can fire. That shows the information is present, not that the model actually uses it. A clue is not yet a mechanism. The standard has to become causal. A correlation tells us where to look. A mechanism tells us what must happen if we intervene on one part and hold all the rest fixed. So the test is simple and strict. Name the path. Trace the flow. Intervene on one point, ablate it, or swap in its value from a different input. Then predict which way the answer's probability should move. If the path is load-bearing, it moves. If it doesn't, the explanation was wrong. This is why LLMs are not the final form of AI. They made intelligence look like prediction. But higher intelligence needs more than recombination inside a learned distribution. The next step is legible computation, mechanisms we can inspect, compress, test, and verify. Not just intelligence that produces answers, but intelligence whose reasons can be checked. This is the shift NeuralCipher is built for. NeuralCipher. Deciphering learned computation.